Hey guys, it's Dave. Welcome back to another video. Today we're going over a new Peter Beck interview that he did with NasaSpaceFlight Live. They run a great YouTube channel. I'll link it down in the description below, as well as the full interview if you'd like to take a look. It's an extremely long one, so I had to cut out a lot, but as usual, I tried to capture the most important parts from the perspective of investors and what we're trying to find out about the company. But if you just have a general interest in spaceflight in general, highly recommend checking out the full video. Before we dive into that, though, I just wanted to mention once again, in case you missed the last video, we're starting up a investing competition on the Discord server, so anyone can enter. It's based on your percentage return for each quarter and then the year end. So whoever had the best percent return for Q3 is going to win that award, and then Q4, and then the full year, and so on. So if you would like to join up, there's still time to get your Q3 numbers in before the cutoff, and we announce the winner of Q3's investing competition. Since it is on a percentage basis and not a dollar amount basis, if you only have $100 in the market, you can still potentially beat out someone with $1 million in the market. So it's really just fun for everyone. The link to the Discord server is down below. Also, if you can hit like and subscribe, I'd greatly appreciate it. It would definitely help out the channel. So with that, let's head over to the interview and listen to what Peter had to say.
So for starters, the first catch attempt that happened down in New Zealand, the catch and release, if you will. How's Rocket looking at for another catch attempt here in the hopefully near future?
Yeah, so you shouldn't have to wait long for that. You know, the team's hard at work at the moment. You know, the kind of the catch element is you know, we have that we're fairly well defined. We're pretty happy with that. What the team's been working on at the moment is an ability to, you know, basically catch the rocket and then fly it all the way back to either the launch site or an offloading dock. And you can't have, you know, parachute flapping in the wind as you're flying along at 100 knots. So there's additional systems that we've been working on that, you know, constrain the parachute after capture, so that you can fly with a, you know, a rocket under, you know, the helicopter with a streamed parachute at a good velocity, to be able to fly, you know, either back to the launch pad or you know, to another landing zone. So that's where the majority of the work has occurred. We're super happy with re-entry now, super happy with guidance, and yep. Although we kind of released the last one, we've done lots of testing since then, and we're super happy with the catch. But so yeah, we'll go and you should have to wait long, and we'll announce something here shortly, and we'll go and do it again. But I mean, you know, there's silver rockets running down the production line now, you know, as a standard product, and you know, we're pretty much just making this operational at this point. But what I will say is, man, we've learned so much through this whole process that you know, Neutron's design is the way it is because of these learnings. And I think if we hadn't done the Electron reusability program, you know, we would have made a whole bunch of mistakes with Neutron that that you wouldn't have found out until you started flying stuff.
Yeah.
So some interesting things there. It sounds like he didn't come out and say it outright, but perhaps the problem with that first catch that they ended up releasing again was actually around the parachute, and it was kind of flapping around and bothering the pilot. So most of the work they've been doing on has been to secure the chute and make sure it doesn't disrupt the flight back with the rocket. So if they can bring it back from space, re-orbit, re-enter the atmosphere, and bring it and catch it, I have every confidence that they can secure a parachute. Sounds like it's mostly a solved problem right now. Also, just talking about the reusability and how much they learned with the Electron. I think a lot of competitors who are trying to make their first reusable rocket a larger one without having the benefit of doing reusability before will run into a lot more problems. So Rocket Lab does have a bit of an advantage there.
Yeah, so and you know, whether a vehicle is reusable or not is kind of dependent on a few things. One is you know, the trajectory, obviously, and the performance margins in the vehicle. You know, we lose about 10 to 15% of the performance of the vehicle with reusability, so depending on how much margin. And then the final one is, you know, is the customer. So you know, the silver rocket you saw launch was obviously for the NRO, really important payloads, really important customer. and that wasn't really one that we wanted to experiment on in any way, shape, or form. Sure. So we can fly them in expendable mode or reusable mode. But yeah, at the moment, I'm not sure. Can't remember if it's every fourth rocket or don't quote me on that. But periodically, every one is just a reusable vehicle, and we either kind of put it to the one side for a reusable mission, or obviously reuse it. That's the best case. Mm-hmm. Or if we have to fly it, just fly it. Like the cost of a reusable vehicle versus a standard vehicle is almost negligible.
So interesting to hear that it doesn't actually cost much more to make a vehicle reusable versus their standard Electron. I know we saw them fly the NRO mission on one that could have been reused. So if that had been more expensive, it would have been a bit of a downer, but clearly that's not the case. It still costs about the same. And I don't think we had actually heard before the margin taken up by the reuse. So I'm assuming those extra parachutes and other factors mean that you can have less payload, about 10 to 15%. So now we know if a mission is using really all the way up to that 300 kilogram capacity, that's not going to be reusable. We need something 10 to 15% below it as one of the factors that will allow a mission to be reusable. Also, I was not aware, or at least hadn't heard before, that roughly once every 4 rockets coming off the line are reusable. Sounds like a pretty reasonable number to me, because the expendable ones, obviously it's just one and done, but if you get a reusable one, you can reuse it several times. So even if you're reusing about half your launches, you may only need to build a quarter of your rockets as reusable because they keep getting used multiple times.
And you've gotten data from those, surely. What has that data looked like? And have you been able to test fire or perhaps even reuse components from those vehicles, even though they weren't brought back dry?
Oh, totally. Yeah. I mean, we've re-entered, and we've re-entered 5 vehicles, and I think 3 of them we've put back in the factory. And of those vehicles, we've stripped components on, like whole press systems. We've reflown. We pulled engines off and serviced them, and hot-fired engines. No, we're that bit I'm not worried about. Like we're looking super good there, and the re-entry environment, we've got it smoother and smoother every time, and it's looking super good. So very, very happy with that.
So not a ton new we haven't heard there before, but I just included it to emphasize that it's looking very good for reusability. It doesn't look like there's a lot of problems left. The rockets are coming back in very good condition. We've seen them hot fire an engine that previously came back in and landed in the water, and they've also reused several components from previously used rockets. So everything on that end is looking quite promising.
What is the turnaround time for the pad that wallops? Like, assuming you just had a list of customers and they just were bringing payloads in on trucks as fast as they possibly can, what would be your limiting factor? Like, how quickly could you actually launch out of that pad?
Oh, the limiting factor at that pad, would be a couple of things. One is the team size. At the moment it's sort of set up for 1 a month cadence, but if we wanted to do more than that, then we need to swell the team size a little bit. As I mentioned, the ICF is capable of processing 2 electrons simultaneously, so so that gives us a lot of scope to grow there.
Gotcha.
If we need to increase that cadence.
So we're looking at about 1 Electron a month currently being able to be launched from the United States, and of course we still have 2 more pads in New Zealand, so we're looking at definitely well over the target 2 per month capability. It remains to be seen how many will actually fly, if we'll hit that 1 a month capacity, or if it will be under that, depending on customer readiness.
Well, the beautiful thing about this site is like what you don't see in that image there. What you do on the slight right is that road on the right there is the main entry to the base.
Yep.
So the main gate is
right here.
You can see the main gate.
Yeah.
So roll it out of the factory just down the road onto the pad is pretty awesome.
Yeah. So this is just outside of the Wallops fence line, I guess, and you just right through the main gate there, and then the launch pads are up this road over to one side.
Great to see just how close it is to the launch pad. You don't have to transport your rocket halfway around the country like a lot of these makers do. Have to worry about making the rocket small enough that it can fit under bridges and stuff like that. Deal with all sorts of extra headaches with the transport. Completely a non-factor here. I would think it would help with margins as well, at least in a small way.
Because on a previous episode of NasaSpaceFlight
Yeah.
Live, we were talking about Electron reusability, which involves marine assets and boats to aid recovery.
Cool looking
and
picture.
you were not totally a fan of those because they're frustrating.
I'm still not a fan of those.
He's still not a fan of them.
Frustrating though sometimes. Is that
Yeah,
it?
yeah.
Maybe.
Yeah, look. So, firstly, this is a rendering of in a fully developed state.
Right.
Sure,
So
sure.
you can see all the elements there. Neutron is you can do an 8-ton to orbit return to launch site launch. It does a 13-ton to orbit downrange landing. And obviously, to do a downrange landing, you have to have a marine asset.
Right.
So that's what we have depicted in that artist rendition there is a downrange asset for those 13-ton launches if required.
Okay, so it's not like we were speculating at first when we saw this image. Like, well, is that actually like a barge or something like that? Is that just a pier? Like you should put a Ferris wheel on it or something like that? But this
Yeah.
is actually going to float off into the distance and get a rocket landed on it, and then return over here, and it sort of docks here. This is kind of what's going on with the two. Are those train tracks?
Yeah. So if you look at the building on the far right, the rollover. So that rolls over and basically picks the vehicle from the barge, and then pulls it back onto the launch site.
So the entire building here sort of rolls
Yep.
out on those tracks,
Yep.
and it's got cranes, infrastructure, stuff like that. So it's not.
Yep, a hook on the top. Yep.
Okay.
I had no idea.
That's cool.
That makes a lot of sense. You know what? I had never even made that connection, but now I totally see it.
That's super cool. I had no idea that whole building can move. Interesting idea. Just move the building the rocket is going to go into out and have it pick up the rocket and bring it back. Yeah, I like it. The other thing, when I first watched this live, we did a live stream, I did not know that was a barge. I thought maybe it was just some kind of landing platform, or they were just putting a little bit of extra distance between where it would land and there were other facilities. But yeah, that's actually a barge that would go off downrange and have the rocket land on it, which is interesting because previously Peter has been very much against marine assets. He's mentioned it in the little interview there. They're very expensive and he wants to avoid them wherever possible. But if you need that 13 tons of performance, I guess this is really the only way to do it. So we finally given into that pressure and we will have a barge, it looks like.
And the launch cadence will be relatively modest to begin with anyway. We'll follow basically the same path as we did with Electron, sort of 3 the first year and then 6 the second year and then so on and so forth. So,
Okay.
So we're this isn't our first rodeo. We've played this game before.
Right.
It's just completely absurd to just say you're going to go out and do like 12 launches in 1 year with the first time of a vehicle.
So maybe that's a little disappointing for some people. We're only looking at 3 Neutron launches the first year, then we'll go up to 6, and then it will continue to rise. I don't have a good sense of what he would consider a steady state rate to be, like what their max cadence would be. But it's very reasonable. I think what we see from Rocket Lab is that they say targets they can hit, and they actually hit it, as opposed to some other companies that are very aspirational and just throw out these numbers without really knowing if they can hit them or not. So I think we can be pretty confident that they're going to hit at least somewhere close to those numbers.
I got to ask real quick, since we've got this rendering up, does it launch from here? Is this the launch pad?
Correct. Yep.
I'm not seeing a lot of like flame diverters and stuff like that. It's just on a sort of a pedestal.
Pedestal. Yep.
Yeah?
Yep. No, that's the plane. Yep.
Okay.
I mean, there is a little bit more going on there than is
Just in the render.
It's depicted in the render.
Yeah.
There is a flame.
Okay, yeah, I didn't realize that was the launch either. It just looked kind of like it was sitting there. But yeah, definitely just a render, not, everything exactly as it will be, but definitely interesting to look at that launch site in more detail.
Neutron's trajectory, we actually hold on to the first stage a bit longer and burn it longer than you would on a traditional launch vehicle. But if you actually look at the vehicle, you notice that the second stage versus the first stage is kind of almost quite dramatically small.
Yeah.
Right.
And the reason to do that is that when you've got an expendable upper stage, that's the bit that you're not recovering. Mm-hmm. So the least amount of material in there, the better, and the least amount of work that upper stage needs to do, the better as well.
Gotcha.
So if you look at the upper stage, it looks quite surprisingly small compared to the first stage. But the first stage is the bit we're getting back. It's the workhorse. So fundamentally, we're trying to make the first stage do more work than the second stage for those reasons.
Makes perfect sense to me. We're looking at trying to optimize for reusability as much as humanly possible. So they're really beefing up the part that they're keeping and making the part that they're losing every time as small as possible. Still not fully reusable, but with this size of rocket, this is really the best you can get, at least as far as I'm aware.
One thing is absolutely inevitable is there's going to be more and more human spaceflight as time goes by.
Sure.
Today, there's really one customer, and that's NASA. So, if you want to be purely analytical about it, I mean, there's not a great market right now.
Right.
But I think my personal view is that will change. That will change in the future. So, it would be remiss of us to not be thinking about this now.
Yeah, so it's something I've said before. I've been a little worried about human space flight, what's going on with the International Space Station. Its life expectancy is 2030, and that could be reduced with the situation with Russia and what they might want to do with their half. We really don't know. There's a lot of question marks right now. But it's good to see that these guys really believe human space flight is going to keep expanding, whether that be to new commercial space stations, space tourism, who knows, maybe to the moon and beyond. Although I doubt this capsule will be going to the moon, but they definitely see a market for it, which is definitely good to hear.
The whole point of this engine is just to be super reliable. We don't want an engine that it is all at all stressed in any way. We want to use this engine over and over and over and over again. Generally, a closed cycle engine or an oxygen-rich cycle. You're doing that because you want to extract every bit of performance out of the engine. So you're doing that because you want really, really high chamber pressures, you want ridiculously high ISPs and really high thrust to mass ratios out of the engine. That's the reason why you go down that path. We went down the path for a totally different reason. Because we said, well, okay, what happens if we don't have those requirements? What happens instead of an 11,000 psi chamber pressure, we have sort of a 1,500, 2,000 psi chamber pressure? What does that do to the cycle? And actually, some interesting things happen is that when you kind of take that cycle, remove the requirements for really high chamber pressures and ISPs, you end up with a super robust cycle because the turbine temperatures are just cold, they're just cold, and the surface speeds are just super low.
Right.
So you get all the nice things about this particular cycle with really good throttleability, and you also have an avenue if you need to, if you have a moment that you can really throttle this thing up and eat into some of those margins. But we think the actual lifespan of the engine is vastly improved.
So interesting to hear him talk about that. There's been a lot of talk about their new redesigned Archimedes engine after Investor Day, and I had to admit I'm not a rocket engine expert, but what he was saying is very interesting. They're really optimizing around reusability and making sure the engine can handle many, many launches, landings, relights, as opposed to trying to push it to the limit like some companies seem to be, trying to get the highest pressure, highest bar, highest ISP. If you take it a little bit easier, then maybe you can make it last longer, which is what you really want with a reusable vehicle. So definitely an interesting kind of counterintuitive way of thinking about their engine on this one.
I like that because we hear, all the time, people are like, oh, we've done methalox and, oh, we're pushing the boundaries, so many bars, so many PSI, chamber pressure, oh, it's all crazy, right? And in some cases, you could really try to push the boundaries there. But if you're not trying to push the boundaries, you could just end up with a way more reliable engine. There's no reason.
It's what are you optimizing for?
Yeah.
And, we're optimizing for a workhorse.
So I think I already said everything that I had to say about that one.
I think the thing that's going to really enable, in my opinion, humans to meaningfully leave Earth is propulsion. We're still burning dinosaurs, and until we get away from that, then we need like a step change in ISP.
Yeah.
Because if you look at a rocket it is today, it's still like between 2 and 5% of the total rocket's mass is the payload you're lifting to orbit,
Yep.
and you're still sort of 90% plus fuel. So, as far as like a thermodynamic system or an optimized system, anything that says that sort of 2 to 5% of your whole system is actually the work delivered, it's pretty poor efficiency.
Right.
I mean, you imagine if your car was 2% efficient, it wouldn't be a stunning thing.
Right.
So I think the thing that's really gonna be a step change is if we can solve this kind of propulsion ISP problem, where the mass fraction of the rocket is like 20% or 40% or something like that, and ISPs in the thousands. I think that's when we really enable really enable stuff.
Gotcha.
So that one's not too pertinent to the business. I just found it very interesting. As far as I'm aware, we're not anywhere close to a breakthrough like that. I don't think chemical rocket engines can ever get to that kind of mass ratio he's talking about, where we don't have 90% of the mass of the vehicle being fuel. Definitely a different philosophy than being taken by SpaceX, though, as they're really trying to optimize and have a step change in mass to orbit for the price of mass to orbit, despite having 90% plus fuel. So they're just going to burn massive amounts of fuel, and through reusability, just bring down the price that way. But Peter seems to have some different thoughts on it. I'd be interested to hear in the comments if there's any theoretical technologies in the future that could potentially give the kind of ratio of fuel versus mass to orbit that he's talking about here, because I'm not really aware of any.
Is Electron going to continue forward? Do you envision a time where Neutron is flying everything and you're not flying Electron anymore? How do you see that sort of working out?
No, I mean, Electron will continue as a product. I mean, there's a real market niche for it there in small dedicated launch. That's not going away anytime soon, and nor can it be replaced with a large launch vehicle. So we have absolutely no intentions to retire Electron at any point. In fact, Neutron will help Electron, and Electron will help. It has already helped Neutron. There's a lot of commonality between things like avionics and software. And
so that was nice to hear. Clearly, he doesn't think Electron can be replaced by a larger launch vehicle, so Neutron is not going to be cannibalizing the customers from Electron. Also, he doesn't seem to think that Starship has the potential of stealing away customers from Electron either. Even though it's planned to reduce costs of launch, it'll just be an extremely massive ship for what is a small sat launcher. They've also made massive amounts of investments into Electron over the past, so it's nice to see that those will continue bearing fruit into the future. And hopefully, as we don't have to invest more into R&D around Electron and reusability in the future, we'll just have more revenue hitting the bottom line and become more and more profitable as a business line.
Yep.
Could you foresee any future enhancements to Neutron where it's like Neutron XL, you stretch the tanks a little bit or something like that, and you use that extra margin to carry a little bit more to payload or anything like that? Gone across the drawing board?
Yeah, totally. And in fact, the way that Neutron is architected, actually, if there was a need to increase its size, then it's a relatively academic process. Excuse me. So there's plenty of scope for that. I mean, we don't size a vehicle just kind of pick a number and away we go.
Right.
We've one of the advantages of flying Electron so much is we get to work with so many different customers around the world, and that's what has really driven the sizing of Neutron to date.
So that was our last clip there, just talking about Neutron, and what really came across to me is how flexible Rocket Lab is. They're really able to change things based on mission parameters. They were able to push the Electron limits from 300 kilograms to get 320 for that capstone mission. So they seem to be pretty confident that if needed, they could also push Neutron's limits, make it a little bigger if needed, and really just continue to be flexible based on customer needs, which you like to hear, of course. And maybe a Neutron Block 2, Block 3, and see things change and continue to improve down the line. So that's it for this video. Thanks again to NASA Spaceflight for the great footage and interviewing Peter Beck and asking some great questions. If you're interested, please do check out the entire video. Link is down below. Give them a subscription if you like what they do. Also, give me a subscription if you enjoyed the video. I'd really appreciate it. And I hope to see you in our Discord channel. Link in the description below. I'll see you guys next time. Bye.